Welcome to Proving Lines Are Parallel Part 4. Right? So in this lesson we're going to be strictly doing proofs, right? Formal proofs or some informal proofs. Here we want to prove, the beginning of a proof is generally given information. The end of a proof is always what you're asked to prove. And in between those, you are making statements that you can connect to each other based on definitions, theorems, postulates, rules for geometry, rules for mathematics. Right? So I have all the statements here that are connecting them, and then we're going to fill in the reasons. Right? Sometimes you're going to be given all of the statements and you fill in the reasons. Sometimes you'll be given some of the statements and some of the reasons, and sometimes I may ask you to develop the statements and reasons yourself. Right? So start with what you're given, right? And each time you're trying to think of how that's going to get you closer to what you want to prove. Right? So let's look at our first statement. J is parallel to K. Right? Well, it's right in the box here, right next to the words given. Right? So that is a given piece of information. I think my whole proof, oops, forgot my pen was in my hand. I think the whole proof moved there when I tried to underline. Right? So this is given. We can be given statements or we can be given picture clues. Angle 1 and angle 4 are supplementary angles. Right? So now let's take a look at where they're located. Right? Here's angle 4, here's angle 1. Right? So those are not a linear pair. What kind of angles are they? Well, think about what we just said. We said that line J was parallel to line K. And when we have parallel lines, we know certain things about certain angles. Right? We know certain angles are congruent. Our corresponding angles, the alternate interior angles and the alternate exterior angles, are congruent. And we know that consecutive interior angles are supplementary. Consecutive interior angles are between parallel lines on the same side of a transversal. So these here are consecutive interior angles. And if we know our lines are parallel, then those angles that are between the lines on the same side, the consecutive interior angles, have got to be supplementary. Right? So our reason is consecutive interior angles. And if we can squeeze in created by parallel lines, let's abbreviate. We'll drop the word created and we'll just put in by parallel lines. Otherwise we're going to run out of space there. Right? So because we have parallel lines, right, the consecutive interior angles have to be supplementary. Measure of angle 1 plus the measure of angle 4 equals 180. Right? Well, that's just what supplementary means, right? Supplementary means the angles add up to 180. That's just the definition of supplementary angles. I can squeeze supplementary in, but I'm going to have to abbreviate angles. Measure of angle 4 equals the measure of angle 7. All right, so now let's take a look. We've got 4 circled already. Here's angle 7. Right? What kind of angles are those? Right? Well, those are vertical angles. Now why would I bring in angle 7 here? Well, look at what we're trying to prove. We're trying to prove something about angle 1 and angle 7. We've already got angle 1 in the proof, right? Because we've mentioned that these are consecutive interior, that angle 1 and angle 4 are consecutive interior angles. But we don't have 7 in the proof. So we need one of the angles there, that would connect to angle 7. Angle 1 doesn't have any specific relationship to angle 7, but angle 4 and angle 7 do, because we know those are vertical angles. So this is the vertical angle theorem. Vertical angle theorem says that if you have angles that are formed by intersecting lines, they share a vertex, they're opposite one another, they are going to be congruent. So vertical angle theorem, and that's an abbreviation for theorem. Measure of angle 1 plus the measure of angle 7 equals 180. Now remember, we're trying to say something about angle 1 and angle 7. Right? So notice I have this statement here. Right? We know that angle 1 plus angle 4 equals 180 because they're supplementary angles. They're consecutive interior angles. And we want to say something about angle 1 and angle 7, that they're supplementary angles. So notice it's almost the same statement, except instead of measure of angle 4, it has the measure of angle 7. What did we do to the measure of angle 4? Well, we just replaced it, because angle 4 is equal, the measure of angle 4 is equal to the measure of angle 7. So when you replace one angle, or one of anything, with something it's equal to, you're just doing a substitution. You're substituting one equal quantity for another. So this is substitution property. Now that we know that the two angles add to 180, we know they have to be supplementary. Our last statement has to match what we have right there by prove. Right? So now that we've said the measure of angle 1 plus the measure of angle 7 equals 180, we know they have to be supplementary angles, because that's the definition of supplementary angles. So this wasn't a proof to prove lines parallel, but we did use some lines that were parallel in our proof. Right? So if you did not have the reasons in here, you would go from what you're given there, that J is parallel to K, and try to get angles 1 and 7 in that particular proof. And since you want to prove they're supplementary, it would be a good idea to choose a pair of angles that have to be supplementary and one that you could justify. And that's why 1 and 4 were chosen. Right? So here's this proof right here. Right? And so every statement is justified with the definition, theorem, a postulate, a reason. There's a reason we can make each of these statements. Okay? And that's what a proof is. Completely justified argument to show that something is true. All right, let's take a look at the next one. There's 6, I think, altogether. All right, so this one has no statements written in and no reasons written in. So we're going to do it here, look at the diagram to make a plan. You want to have an idea of where you're headed with the proof. The diagram suggests you look at angles 1, 2, and 3 because they bothered to number those. Also, you may find it helpful to focus on one pair of lines and one transversal at a time. Right? And so we know something about lines A and B, and we're trying to prove something about about lines X and Y. It would make sense to start with what we know, lines A and B. It would also make sense to start with information we know to be true. For instance, we know that line A is parallel to line B because that's given. Now that I've made the statement that the lines are parallel, I can say anything I want about the angles that relates to the parallel lines. For instance, notice angles 1 and 2 that are formed by lines A and B with transversal X. And so right now, X is a transversal for lines A and B. So something I can say about angles 1 and 2, I can say that angle 1 is congruent to angle 2. That gets both of those angles in there. And we're trying to prove something about our lines X, Y there. And it makes sense to use the angles that were given, because then maybe we could say something about some angles that are formed by lines X and line Y. All right, so why can I say angle 1 is congruent to angle 2? Well, those are corresponding angles formed by parallel lines. It's important that those are only congruent when my lines are parallel. All right, so and it's also a good idea to mark your diagram. All right, so now that I've said that angle 1 is congruent to angle 2, I should actually mark that on the diagram. And so that's probably all I want to say. The only statement I want to make that form from that lines A and line B are parallel, right, is the fact that those angles have to be congruent. Because now I think I want to say that angle 1 is congruent to angle 3. And the reason we know that to be true is that's a given piece of information. So notice I didn't say both givens at this, one after the other. Not that I couldn't, but it made sense to make a statement off the fact that the lines are parallel. Now that I've said angle 1 is congruent to angle 3, I can now make this statement. I can say that angle 2 is congruent to 3. That is supposed to be congruent symbol. There we go. Well, why can I make that statement? Well, if you look at the two statements right above that one, notice that both angle 2 and angle 3 are congruent to angle 1. Right? So if you know that you've got two angles that are congruent to the same thing, they have to be congruent to one another using the transitive property. And so the whole time with this proof, I was headed towards getting angle 2 congruent to angle 3 because we already knew angle 1 was congruent to angle 3. And if we mention the parallel lines, then we can say angle 1 is congruent to angle 2. And that would free us up to use the transitive property. And I'm just moving things up because I got to get my last statement in here. Now that we've said, and I still can't get it in if I move these up. Now that I said that angle 2 is congruent to angle 3, we now can say something about our lines. Let's take a look at these angles, and I'm going to mark angle 3. Right? So all three of those angles are congruent to one another, but the important ones for proving line X parallel to line Y is 2 and 3. So now we've got enough information to say line X is parallel to line Y, and the postulate we're using, there's only 4 for proving lines parallel. These are alternate exterior angles. So we're using the converse, I'm going to abbreviate that, of alternate, I'm going to get rid of the word of. Converse, alternate, we're going to abbreviate exterior angles. There we are. So the converse just says we're going to go the opposite direction, right? Meaning we know the angles are congruent. We want to show the lines are parallel. So that's the converse. The alternate exterior angles theorem, our postulate, says that if the lines are parallel, then you know those alternate exterior angles are congruent. So this is going the other direction to prove the lines parallel. And we've done it. 5 steps. Right? So here you see how you relate what you're given and what you're trying to prove. Let's do another one. Right, so this one has the statements. We're going to fill in the reasons, and we're trying to prove that two lines are parallel. This, by the way, is a proof of one of our theorems. Right, so we're trying to prove consecutive interior angles. I'm going to capitalize that. So we're trying to prove consecutive interior angles postulate. Right? We're trying to prove that. Right? So we can't use the fact that, I mean, if we know 1 and 2 are supplementary, right, we would know the lines are parallel using consecutive interior angles postulate. Right? So here we're actually kind of trying to prove the postulate by using that piece of information and showing that we can prove these lines parallel another way. So at no time can we use consecutive interior angles postulate. Right, so angle 1 and angle 2 are supplementary. That was our one piece of given information. By the way, most of these are in your notes, so make sure you're filling along with me. Really, all it takes to be able to do proofs is a little knowledge and a little practice. So, by the way, while I'm doing these proofs, we're really be trying to think of the reasons that I'm making each statement, or think about the statement I'm going to make next if the statements aren't already filled in. So, measure of angle 1 plus the measure of angle 2 equals 180 degrees. Why can I go from supplementary to saying that they add to 180? Why, that's just definition of supplementary angles. Did you remember that from the last proof? Actually, not the last proof, but 2 proofs ago. I'm really going to have to abbreviate supplementary. There we go. measure of angle 1 plus the measure of angle 3 equals 180 degrees. Now, even though those two statements, this one and this one, look very much alike, this is not a substitution. Instead, if we look to our picture, we can see that angle 1 and angle 3 there, right, those are adjacent angles, right, formed by intersecting lines, and together they add to 180 degrees because they are a linear pair, right? So the reason that we know that angle 1 plus angle 3 equals 180 degrees is definition of a linear pair. That's what a linear pair angles add up to. You could also say linear pair angle postulate. Either one would be okay. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. Now notice these two statements here, these two right here, both of those things add to 180. So if they add to 180, they add to the same thing, they have to be equal to one another. That's the transitive property. That's a V. All right, so now we've gone from the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. Notice something is missing from both sides of the equation here. Right? Notice we are missing angle 1. What did we do to angle 1? Why, we subtracted it. So to go from angle 1 plus angle 2 to just angle 2 and equals angle 1 plus angle 3 to just angle 3, we use the subtraction property. And technically they have two steps kind of squeezed in here, so let's just make the next step here like 22 and a half. Notice they have two things here. They went from the measure of angle 2 equals the measure of angle 3 to angle 2 is congruent to angle 3. They really should have given that its own step down here. However, the reason we can go from the measure being equal to them being congruent is that definition of congruence. And I am trying to figure out, I'm going to move property. I really can't abbreviate subtraction, because if I put sub, it looks like substitution. Right, so if I move property up there, I can fit in definition of, and we're going to use a symbol for congruence. Definition of congruence. Right, so congruent just means you have the same measure, or if you have the same measure, you are congruent. And now we can say that line 1 is parallel to line 2, and indirectly we have proven the consecutive interior angle postulate. Right, so let's take a look at the angles here. We should mark them. Angle 2 is congruent to angle 3. What kind of angles are those? Why, those are corresponding angles. And actually this is the converse, since we're proving the lines parallel. So this is the converse of the corresponding angles postulate. So how many of those did you know? Hopefully you knew a whole bunch of them, because a little later on this week, you're going to be completing your own proofs without me. Well, maybe I'll help you. All right, so here's another one. We have the statements and not the reasons. So we're going to fill in the reasons here. And always makes sense to start with something you know, and that something you always know is things that you are given. So we're given angle 1 is congruent to angle 4. That is a given piece of information. Measure of angle 1 equals the measure of angle 4. So let's talk about this proof actually before we go any farther. We're trying to prove the lines parallel. We're given some information. We're given these angles are congruent. But the lines we're trying to prove parallel are L and M. And notice that angle 4 there is on line N. Right? So angle 4 is really not helping us on its own. However, we can use that piece of information to get some angles on line M, to get to know something about the angles on line M, and then we can prove that line L and line M are parallel to one another. right? So that's the information we have, right? And we're trying to figure out some things so that we can prove that line L and line M are parallel. Right? So it makes sense to start with what we're given. The reason you'd want to change from congruent to measures and equals is if you want to have a math statement, an equation. That's what I'm trying to say, an equation, like we have in steps 4 and 5. Right? I need to change from congruent to equals, right? So that I can just plug that in, right? So it's the measures that we're adding up, right? Not per se the angles. Right? So measure of angle 1 equals measure of angle 4. That's the definition of congruence. We just went from congruence to equals. Now I can write out the word congruence. Angle 3 and angle 4 is supplementary, right off the top here, given. Right, so angle 3 and angle 4 is supplementary, means that they add to 180 because that's what the definition of supplementary angles is. Measure of angle 3 plus the measure of angle 1 equals 180. Notice exact same, so 4 and 5 here are the exact same statement, except one thing. 4 has been replaced with an angle 1. We can do that because the measures of those two are equal. You can replace one thing with something it's equal to, right? So if you're replacing something with something it's equal to, you're making a substitution. Substitution property. That could be written a whole lot nicer. One other thing is there are often more than one way to prove something, right? So the way I'm showing you is not necessarily the only possible way it could have been done. It's just one way that it could be done. Angle 2 is equal to, the measure of angle 2 is equal to the measure of angle 3. Right? So let's take a look at our picture clue. Right? So if there's not something in the proof, go back to your picture clue. It's also a good idea to mark these. What's special about angle 2 and angle 3? They're vertical angles. So we know they're congruent using the vertical angles theorem. Measure of angle 2 plus the measure of angle 1 equals 180. Now notice this statement at number 7 there looks an awful lot like the statements at steps 4 and 5. Right? We didn't replace the 1. This time we replaced the 3. Right? We replaced the 3 with the 2. Right? So instead of measure of angle 3, now it says measure of angle 2 plus the measure of angle 1 is 180 degrees. Well, notice angle 2 is congruent, is equal to angle 3. So if they're equal, they have the same measures, I can replace one with the other. And we just made a little substitution again. So when you're trying to prove lines parallel in a proof, see which of your postulates, your 4 postulates, alternate interior angles, alternate exterior angles, corresponding angles, or consecutive interior angles you can use. Right? Consecutive interior angles made the most sense here, right? Because we've got some information about a pair of consecutive interior angles that are formed along lines L and M, mainly angle 1 and angle 2. Right? We've got some vertical angles with 2 and angle 3, and we know things about angles 3 and angle 4. Right? So we've got angles that are in between those lines. It makes sense to try to prove that line L is parallel to line M using the converse of the consecutive interior angles postulate. And there we have it. Right? So we've proven the lines parallel, right, using our given information and connecting it to ultimately be able to show what we want to prove is true. I think we have maybe a couple more. Right, so parallel line theorem. So if you noticed here, we had 3 lines. We knew that, well, we didn't really know that line N and line N are parallel based on our information that we're given. Right? Actually, we did know. Well, we could have known. We could have shown it. So here we're given information about angles 3 and angle 4 supplementary. Those are consecutive interior angles. Right? So because angle 3 plus angle 4 equals 180, right? That means that line M had to be parallel to line N. Right? So we knew some things about those two lines. And now we've proven that line L is parallel to line M. So since L is parallel to M and N is parallel to M, what do you think that must mean? Well, it must mean since these two lines are parallel to the same line, they must be parallel to each other. Right? You can't have two, if these two are parallel, and these two are parallel, all three of them got to be parallel. That's the only way it would work. And so one of our last little definitions, theorems, postulates in this particular lesson, parallel lines theorem. If two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. Right? So if they're both meeting the same line at a 90-degree angle, well, they have to both be parallel to one another. Right? So you can add to your notes there, lines perpendicular to the same line are parallel, a little abbreviation. And this is how you could list it in a proof, right? So you could put it this way in a proof. So you don't have to write the whole thing, right? So here I've got a little abbreviation for it. And parallel lines theorem. So if two coplanar lines are parallel to the same line, the two lines are parallel to one another. So here we have line M parallel to line N, line O parallel to line M. Since they're both parallel to the same line, line N has to be parallel to line O. The other two have to be parallel. Right? And here you can abbreviate this in your notes. So if you want to use that in a proof, lines parallel to the same line are parallel. And what happened to the word are? Let's add in an R there. If you're desperate for space, you can leave off the R, but we'll try to make that a sentence. Right? And so you can use that as a reason and proof, so you don't have to use the whole thing. You've got the important parts in there. And so parallel line theorem is what we ended up in kind of indirectly showing in this last proof that we just did. Right? And so we've done some proofs, we've learned some new theorem. This is my last page. This is in your notes. We want to determine whether there's enough information given to conclude that line M is parallel to line N, and explain. I like to think of these as kind of like short paragraph proofs. Right? So in sentences, we're showing that one of our theorems is true or isn't true, all right, or not known to be true. Let's put it that way. Right? So are one of those four theorems that tells us lines are parallel, is it true? Or is it not known to be true? All right, so let's take a look at our first one. All right, so notice we've got some congruent angles here. Think about what kind of angles they are. Same side of the transversal, same position on one of the lines. Those are corresponding angles. So we know that line M has to be parallel to line N because the corresponding angles are congruent. So the lines are only parallel if the corresponding angles are congruent, and if the corresponding angles are congruent, the lines have to be parallel. So likewise now that we know the lines are parallel, everything else that would be true, like the alternate interior angles would have to be congruent and the alternate exterior angles and so forth. But it was the corresponding angles that told us these lines have to be parallel. Because we know every time corresponding angles are congruent, we're going to have lines that are parallel. Right? So this is sort of like a little mini proof. You didn't have to get to the thing. You just had to use it to be able to show the lines are parallel or not. Let's look at number 2 here. We've got vertical angles. So notice the vertical angles are only on one line. They're just on line M. Right? And let's think, when are vertical angles congruent? Is it when the lines are parallel? or is it when it's all, or is it all the time? Get my sentence out there. Or is it true all the time? Well, we know that vertical angles are always congruent, and therefore the information, or given information, does, should I write down here? Not prove, right over here, not prove that line M is parallel to M, N, right? I don't want to say they're not parallel, because I don't really know that they're not parallel, but I certainly don't know that they are. So vertical angles are always congruent. The given information does not prove that line M is parallel to line N, right? Just not enough information at all. Let's look at the next one, number 3 here. We have some angles that are congruent. There's nothing special about these angles. They're not alternate interior angles. They're not alternate exterior angles, right? They're not corresponding angles, right? They're just two angles there. So, would it make our lines parallel or not? Well, let's think, all right? So, we know, let's figure out what angles would have to be congruent, right? So, we know that this angle here, right, would have to be congruent. If the lines were actually, let's stick with if the lines were, no matter what, whether the lines are parallel or not, right? So, this angle has to be congruent to this angle, right? Because these are vertical angles. So here we're going to have to kind of make sure by using all the things we know, right? So we know those have to be congruent because they're vertical angles. We know, I'm going to mark this in a different color. Right? We know these have to be congruent because they're vertical angles. Now let's think what would have to be, let's take a look right here, what kind of angles we have right here on the inside. These are consecutive interior angles. And we know if the lines are parallel, I'm going to write it up here. So when lines are parallel, we know that the consecutive, I'm going to have to really abbreviate here, interior angles are supplementary. So they have to add to 180 degrees. But they're marked as congruent. So what would the only way this could possibly be true for those to be both congruent and supplementary is if those angles were 90 degrees. Right? So since our consecutive are congruent, that means that line M is parallel to line N only, oops, sorry about that, if all angles are right angles. That would be the only way that this would work out. Go back and go forward. So, are the lines parallel? Probably not, right? Because our consecutive interior angles are marked as congruent, not supplementary, and we're not told that these are right angles, right? So we know when lines are parallel, the consecutive interior angles are supplementary. Since our consecutive interior angles are congruent, M is parallel to N only if all the angles are right angles, right? And this is not shown to be true. Right? We don't know those angles are right angles. They're not marked as right angles. Right? So we know that the pairs of vertical angles have to be congruent. That would mean that if these lines are parallel, all these angles are congruent. Because then you'd have your alternate interior angles, your alternate exterior angles, and every single angle here would have to be 90 degrees, right? Because we know we have parallel lines. All the angles are either congruent or supplementary. And since those consecutive interiors are marked as congruent, or can be shown to be congruent using vertical angles, the only way those lines are parallel is if all those angles are right. Our last one actually is pretty easy. So notice, actually, number 4 is not very different than number 1 here. You've got corresponding angles are on the same side of the transversal, same position. So M is parallel to N because, here we go, the corresponding angles are congruent. So that's the end of my podcast. I do believe that the next page would be a closing. Actually, that closure there is not a closing. That I intended for us to be a lesson. So that's the end of this podcast and the end of this entire lesson. So hopefully you feel a lot more comfortable with proving lines parallel, and you'll get a lot of practice with your homework and a group work and a classwork. All right? Thanks for watching. Bye for now.